Okay, today we're going to jump into the second section of Chapter 7, which begins on page 428. And what we're going to do today is we're going to look at the graphs of our basic sine and cosine functions. Now, in addition to that, we're just going to take a look at some of the basics of general periodic functions, because sine and cosine are what we call periodic functions. So let's talk briefly about periodic functions, and then from periodic functions, then we will move on and talk about the specifics of sine and cosine. What a periodic function is a function whose graph repeats indefinitely. And that's in both the positive direction and the negative direction. So for example, we might have something, just to kind of sketch you a generic one, we might have something that looks like this. So we might get a function that looks like this. Okay, and this thing would then continue to the right, and it would also continue back to the left. So with these being identical copies, and obviously I didn't get them quite identical, but you guys get the idea, this would be an example of a periodic function that, again, repeats going this way and repeats going this way. So this would continue back down a little bit, and then it would start to zoom back up, etc. You guys get the idea. Okay, there are a couple of key aspects to a periodic function. The first thing I want to talk to you guys about is what we call the amplitude. So let's say this is down at -1, this is +1, +2, +3. The amplitude refers to the y direction. And it's a measure of basically how extreme your maximum and your minimum are. And there's a formula for amplitude. The amplitude is equal to the maximum value minus the minimum value. These are the y-coordinate values we're talking about, divided by 2. So in the case of our periodic function here, as it repeats itself, the maximum value is always the same. It's getting up to +3. So our amplitude is equal to +3 minus our minimum value drops down to -1, divided by 2. So our amplitude is equal to 3 minus -1, which is 4, divided by 2, which is 2. That is our amplitude. Now, it's very important to understand that amplitude is always a positive number because it's defined as maximum minus minimum divided by 2. If you take a big number minus a smaller number, you have to get a positive answer for that difference. When you divide it by a +2, you still get a positive answer for that difference. Okay, so your amplitude will always be positive. Now, sometimes in these equations of our trig functions, you're going to see a negative attached to the number that represents the amplitude. Understand that the negative is not part of the amplitude. The negative is going to indicate a transformation of the graph. In this case, it will be a transformation of a reflection across the x-axis. We'll talk about that when we get into transformations starting tomorrow. So this is our amplitude. So it's 3 minus -1, which is 4, divided by 2 is 2. What this is really telling us, guys, is if I was to break this graph down the center, there's a center line going down the graph where the maximums and minimums are spaced out evenly. What this is really telling us is the farthest that we ever go above that center line is 2 units, and the farthest we ever go below that center line is 2 units. That's really what the amplitude is describing to us. Now, in terms of the real world, what does amplitude represent? Well, one thing that travels or that occurs with periodic functions things like sound waves. Sound waves travel in a sinusoidal pattern according to the sine curve. The amplitude represents the volume. So the larger the amplitude, the louder the sound is. So if you have two different graphs, two different sound waves, and one has a larger amplitude than the other, but everything else is the same on them, then that larger amplitude will represent a louder sound. So that's a physical representation of amplitude. Now, in addition to amplitude, let me just get rid of some of this stuff. Okay. In addition to amplitude, we have the concept of period. Now, in math, we refer to this as period. In your science classes, this is usually referred to as wavelength. The length of the wave, which in science is represented by the Greek letter lambda. We call it period, though, in math. And what the period is the distance that it takes to have the graph repeat one full cycle. It doesn't matter where you start and where you end, as long as you travel a full cycle and then take a look at the horizontal distance that it took to cover that full cycle. The easiest way to do it, guys, is the distance from either peak to peak, in other words, maximum to maximum, or trough to trough. In other words, minimum to minimum. So I'm going to do peak to peak and just show you that, for example, let's say we are at 1, 2, 3, 4, 5, 6. So let's say this is our horizontal scale. So notice that we have a peak here, we have a peak here. And so the distance between those two peaks is the distance from 1. I should have made this a little bit farther over, but you get the idea. From 1 to 4, that's a distance of 3 units. And so whether I go from peak to peak or I go trough to trough, notice from 3 to 6 is also a distance of 3 units. So our period here would be 3 units. Every 3 units in the x direction, our graph repeats one cycle, one period. So those are the two most important aspects of periodic functions that I want to touch on. First is period and amplitude, and they're going to ask you to identify those things from various graphs. Okay, now what we want to do is we want to take a look at our specific periodic functions that we really care about, starting with the sine function. The sine function has a period of 2 pi. Okay, now this is in radians. Remember our x-coordinate here, we're taking the sine of. That means that x is our angle. So that means it's either going to be in radians or degrees, and we typically express these when we're graphing them in terms of radians. Okay, you're really not going to see it in terms of degrees. That doesn't mean that it can't be done in terms of degrees. Our book certainly does not do it. Now, it won't always be in terms of pi. They could give you a period of 4 radians without pi involved. Okay? So that's just an angle. Since pi is 3.14, that's going to be between pi and 3 pi over 2. That's going to be a quadrant 3 angle. Okay? So we can, it doesn't have to be in terms of pi, but it is typically going to be in radians. So our period for our regular sine curve, notice there are no extra numbers or anything else in here. This is our basic parent function sine curve. The period is 2 pi. The amplitude is equal to 1. And so what that means, since the amplitude is 1, our graph is going to go between 1 and -1, because maximum minus minimum divided by 2 gives us 1. Our center line for sine is right on the x-axis. Now, what I want you guys to focus on is not just the shape of the curve, but I want you guys to stay focused on guide points. We talked earlier in the year, last semester, about graphing using transformations and by using guide points. It's very difficult sometimes to draw a graph using transformations by moving the entire graph at once. It is very easy, though, to translate or transform one point at a time. And so we're going to transform each of our guide points when we do transformations starting tomorrow. And then we're just going to connect them with the curve. So for sine, there are 5 guide points. And there are also going to be 5 guide points for cosine as well. I'm sorry, let's spell that correctly. For some reason, my N disappeared. The 5 guide points for sine, first of all, we need to deal with our period. What you always want to do when you're dealing with a period, guys, and an amplitude, the amplitude will be your maximum and your minimum on the y-axis. Your period will go out a certain distance. I like to put it out about that far. And that's what you number that particular point. So that's an x-coordinate of 2 pi, so about 6.28. You're then going to cut that in half. Half of 2 pi is 1 pi. You're then going to cut that in half again. Half of pi is pi over 2. And then you'll have another half over there. Notice that each of these units is now pi over 2. This distance is pi over 2, so this is really a distance of 1 pi over 2. This would then be 2 pi over 2, but 2 pi over 2 reduces down to just pi. The next one would be 3 pi over 2, followed by 4 pi over 2, which simplifies down to 2 pi. So pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Now we have our axes numbered and set up. Now we're going to put our 5 guide points in. The first guide point is at the origin for sine. And sine begins and ends right on the center line, right on the x-axis. And in the middle, it also hits the center line, which is the x-axis in this particular case, since we're looking at just our basic parent function. Now, we have 2 more guide points to put in. Halfway from the center to the middle, sine is at its maximum, up at +1. And halfway from the middle to the end, we're at our minimum, which is -1. Those are the 5 guide points, and this really just comes from making a t-chart and plugging in values. Okay, all we're doing is we're focusing on 5 of those points, and sine is going to be a nice smooth curve. There is nothing linear about it. Do not make this straight lines. Okay, this is not what is called a sawtooth function. Okay, this is a sawtooth function, one that does this kind of thing. Okay, for obvious reasons, this is called a sawtooth. Looks like the teeth of a saw that you would use from your toolbox. What sine does is sine curves up towards its maximum, curves back down, and continues towards its minimum, and then curves back up to that center line again. And so I recommend drawing this, at least at the beginning, as a dotted curve, and then when you like the shape, go back and make it solid. I'm typically going to draw them dotted on the screen, because it's a lot easier for me to get it to look right. It's a little bit tougher if I try and draw it solid. The tablet just doesn't make that very easy. So here is our basic sine curve. So at 0, we're at 0. At pi over 2, we're at 1. At pi, we're at 0. At 3 pi over 2, we're at -1. At 2 pi, we're at 0. Because this is a periodic function, what would then happen, if I extend this out, is we could go that same distance, 4 more units. Pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, which is 3 pi, 7 pi over 2, and 8 pi over 2, which is 4 pi. And so this would be my beginning, my middle, my end, my maximum, my minimum, and I could continue this sine curve for as many periods as I wanted to. So this would be 2 periods of our sine curve. Likewise, this thing would continue back in the other direction. So this would be negative pi over 2, negative pi, negative 3 pi over 2, and then negative 2 pi. Okay, I'm not going to write those in, but that's the way it would work. So one of the things they're going to do is they're going to give you pictures just like this without the numbers drawn in on the x-axis, and they're going to ask you to find the x and y coordinates. And this is the way that you will do it. And these will be the numbers for the x and the y axes because we're not dealing with transformations yet. We're dealing with just the basic parent function. So that is our sine curve. Now, typically what's going to happen when we graph these is typically we're just going to be graphing one period, which means that typically all I'm going to be concerned with is that you draw this portion of it. Okay? And we'll see that tomorrow when we get to transformations. Okay, the next thing I want to talk about is the cosine curve. And cosine works the same basic way with 5 guide points. It also has a period of 2 pi. Let me write that a little bit better. It also has an amplitude of 1. So here's my y-axis, here's my x-axis. Again, I'm going to go out a decent distance. Don't make it too big, but don't make it too small. It's going to make your graph too hard to draw. Half of 2 pi is pi. Half of pi is pi over 2. Here's 1 pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. Again, we're going to go between 1 and negative 1 because our amplitude is 1. And so now we're going to fill in our 5 guide points for cosine. And so cosine does not start at the origin. Cosine starts at the maximum, which is 1. It also ends at its maximum. Halfway, it's actually at its minimum. So these are the first 3 guide points for cosine. And then obviously if we're going to draw a smooth curve through this, then halfway to the middle, we're at 0. And halfway from the middle to the end, we're at 0. And again, this is not a V. This is a smooth curve. And so what you get is you get a curve that curves downward from the maximum, down to the minimum, and then curves its way back up to the maximum. And then if we want, we could obviously continue this for another period. Now you will notice, guys, that if we look at this curve, if instead of starting here, I started here, do you see that this period, if I start over at 3 pi over 2, this is nothing more than the sine curve. Sine and cosine are the same curve. They are just shifted relative to each other, which should make sense to you because think about our unit circle values. Our sine and cosine values, our coordinates, x and y, use all the same values. 1s, 0s, 1/2, rad 2 over 2, rad 3 over 2, and then the negative version of those. And those switch around between x and y. They rotate around. They use all the same coordinates, just in different places. And that's no accident. So here is one period of our cosine curve. So that is how you deal with the sine and cosine curves and their guide points. Okay, the last thing I want to talk to you guys about here quickly is increasing and decreasing intervals. We've talked about that a couple of chapters ago. If we want to know from 0 to 2 pi where cosine is increasing, okay, that means that as we go from left to right, our y-coordinates are growing. So the increasing part of the first period of cosine is between here and here. Now we're increasing from -1 to 1, but that's not what they're asking us. They want to know what values of x do we plug in to get the y values to increase. And so that interval is going to go from pi to 2 pi. The question is, should it be an open interval with round brackets or a closed interval with square brackets when we write it in interval notation? And the answer, as we talked about once before, is that this increasing interval needs to be an open interval. Because at pi, we are we are not yet increasing. We have gone from decreasing to increasing. This is a turning point. But at the turning point, we are neither going down anymore, nor have we started to go up. We're standing still. And so at your maximums and your minimums, your graph is not increasing nor is it decreasing. Therefore, your intervals for increasing and decreasing always need to be round brackets. Now on this particular period from 0 to 2 pi, what is our decreasing interval? It's going to be this piece here from 0 to pi. So that's the idea of increasing and decreasing intervals between 0 and pi for the cosine curve. If we go back to the sine curve, sine is increasing from 0 to pi over 2, and then again from 3 pi over 2 to 2 pi. So that's what's happening between 0 and 2 pi. It's decreasing from pi over 2 down to 3 pi over 2. Okay? Now, here's the difference. Notice that, remember that this graph goes like this. So technically, do you guys see that on the sine curve, at 0, we are actually continuing to increase. We are not standing still. We're increasing before it. We're increasing after it. It is not a turning point. So there's where sine differs a little bit. From 0 to 2 pi, sine is increasing from 0 to pi over 2. But 0 technically is a square bracket, whereas pi over 2 is a round bracket because now we're standing still. It then decreases from pi over 2 to 3 pi over 2. Those are maximums and minimums, so those are going to be round brackets because it's standing still. And then it's going to increase again from 3 pi over 2 to 2 pi. So between 0 and 2 pi only, your increasing interval would be square bracket 0 because it's already increasing when it hits 0 to pi over 2, and then it stops. It then decreases from pi over 2 to 3 pi over 2. And then it stopped at 3 pi over 2, so this is a round bracket, but notice at 2 pi it's in the process of going back up again. So therefore we were increasing before 2 pi, we're increasing after 2 pi. It's not a turning point, therefore this would be a square bracket. So that's the idea of increasing and decreasing on an interval. You need to look and see what interval they're asking you about to decide about the round and square brackets. And look at what the graph is doing prior to hitting that point and after hitting that point. Okay, so that is section 7.2, graphs of sine and cosine and dealing with periodic functions. Do not forget that you need to be taking notes. You need to write down at least one question that you want to bring to class tomorrow, and make sure you bring your notes as well. I'm going to want to see those to make sure that you guys are actually doing your job on the homework and actually watching these videos. See you tomorrow.